Hey there, science explorers! Today we're diving into the exciting world of machine learning, where computers learn to become super smart. Imagine a playground filled with swings, slides, and a giant sandbox. That's our machine learning world, full of possibilities. Now let's meet the stars of our show, Supervised and Unsupervised Learning. These are two ways machines can learn, just like kids on our playground. Supervised learning is like having a teacher guide you, while unsupervised learning is all about exploring and discovering on your own. Get ready for an adventure as we uncover the magic of machine learning. Imagine you're teaching a dog a new trick, like shaking hands. You patiently show the dog what to do, guiding its paw and repeating the actions several times. Each time the dog gets closer to doing it right, you offer encouragement and support, helping it understand what you want. You show the dog the trick, reward them for getting it right, and gently correct them when they get it wrong. Over time, the dog learns by connecting your feedback to its actions. That's supervised learning in action. In this type of learning, we act as the teacher, providing the computer with labeled data information that's already tagged with the right answers. Just like a teacher marks homework, we give the computer examples with clear solutions. Think of it like giving the computer a set of flashcards with pictures of fruits on one side and their names on the other. The computer studies these flashcards, learning to match each image to the correct name. The computer uses this labeled data to learn the relationship between the input, which are the pictures, and the output, which are the names. It practices over and over, improving its ability to recognize patterns and make accurate predictions. The more data we feed it, the better it gets at identifying fruits it's never seen before. With enough practice and examples, the computer becomes skilled at recognizing new fruits all on its own, just like a well-trained dog learns new tricks. Labeled data is like a treasure map for our machine learning models, guiding them through the complex landscape of information. Just as a map marks out the path to hidden treasure, labeled data shows our models exactly where to look and what to find. It tells the computer precisely what to focus on and how to interpret the information it receives, turning raw data into meaningful knowledge. This guidance is essential for the computer to make sense of the world, much like a teacher helping a student understand a new subject. Without labeled data, supervised learning would be like trying to solve a jigsaw puzzle with all the pieces turned upside down, confusing, frustrating, and nearly impossible to complete. The picture never comes together. Imagine you're trying to teach a computer to distinguish between cats and dogs, a task that seems simple to us but is actually quite complex for a machine. You show it thousands of pictures, each carefully labeled as either cat or dog, providing clear examples for the computer to learn from and compare. The computer studies these labels and learns the distinct features of each animal, such as fur patterns, ear shapes, and facial structure, allowing it to accurately classify new, unlabeled images it has never seen before. This remarkable ability to learn from labeled data is what makes supervised learning so powerful for a wide range of tasks, from image recognition and spam filtering to even assisting doctors in medical diagnosis, transforming how we use technology every day. Let's head over to the sandbox, where unsupervised learning takes center stage. Imagine just for a moment a child digging in the sandbox, discovering hidden treasures like seashells and colorful pebbles. That's unsupervised learning in action. In this type of learning, we don't give the computer any labeled data. Instead, we let it loose on a dataset and say, "Go explore and find any interesting patterns you can." It's kind of like giving the computer a giant puzzle without showing it the picture on the box. Unsupervised learning is all about uncovering hidden structures and relationships in data. It's used for things like grouping similar customers together, recommending products you might like, and even detecting anomalies in financial transactions. So, how do supervised and unsupervised learning stack up against each other? These two approaches are at the heart of modern machine learning, and understanding their differences is key to unlocking their full potential. Well, think of it this way. Supervised learning is like learning with a guidebook or a helpful teacher by your side, showing you exactly what each concept means and how to apply it. In contrast, unsupervised learning is like exploring a new city without a map or instructions. You have to rely on your instincts, making sense of the environment as you go, discovering interesting places on your own. When it comes to data, supervised learning uses labeled data, where every example comes with the correct answer, making it easier to train models to recognize patterns. On the other hand, unsupervised learning works with unlabeled data, so the system must figure out the structure and relationships within the data all by itself. The main goal for supervised learning is to predict outcomes or classify new data based on what it has learned from past examples, whereas unsupervised learning aims to discover patterns, groupings, or hidden structures that aren't immediately obvious, helping us make sense of complex information. For example, supervised learning is used in tasks like image classification, where the goal is to identify objects in photos, and spam filtering, which sorts unwanted emails from your inbox. Meanwhile, unsupervised learning is often used for customer segmentation, grouping people by similar behaviors, and anomaly detection, which helps spot unusual activity in large datasets. Both approaches are essential tools in the machine learning toolkit, each offering unique ways to solve problems and extract value from data. Each method comes with its own strengths and weaknesses, and the best choice depends on the problem you're trying to solve and the data you have available. Supervised learning really excels at prediction and classification when given enough labeled data, making it powerful for tasks where accuracy is critical. Meanwhile, unsupervised learning shines at uncovering hidden patterns and insights that we might otherwise miss, opening doors to new discoveries and deeper understanding of our data.